and currently pursues his PhD in artistic research at the University of Bergen. His research as composer aims to explore possibilities of human-computer interaction and artificial intelligence in contemporary music composition. And he's interested in work that explores collaborative and interdisciplinary artistic approaches, and is interested in the interaction between traditional and contemporary musical expressions, real-time processing of sound coupled with instrumental improvisation and unpredictability. So Juan, we welcome you here.
Yeah. Well, thank you. Thank you for that presentation. And I will try to keep this presentation as informal as possible. As my abstract says, I am interested in the possibilities that afford the use of computer-based platforms, computer-assisted tools for music composition. In this presentation, I will describe a computer-based platform that I'm developing based mainly on constraint satisfaction programming, which I have named the Versificator as a metaphor, or maybe as a way of bringing alive the original Versificator, which is a fictional device that George Orwell created in his novel 1984. So I will talk briefly about some of the philosophical aspects behind my research project. And I will give a little bit of historical background. Maybe in this meeting, we probably all know something about it. So just to say, to start, I'll just say that an important concern about this investigation, it deals with, so I'm mostly interested in enriching and expanding a pure musical compositional process within the aesthetics that I'm interested in, which is mostly based on contemporary music. And so this has led me to figure out ways to deepen the relationships between ideas, musical material, and also musical structure. So in a way, you could say I'm trying to find deeper levels of abstraction, which might result in audible processes, but also might result into a way of generating musical structure. So with that in mind, with that concern in mind, that naturally led me to the development of this computer-based platform, in which I make use of several analytic and generative processes that I'm employing in my current compositional practice. So basically, a computer-assisted platform provides you with, an expansion of the symbolic processing power, the capacity with working with a more sort of advanced combinatorial logic, and actually brings you more refined, maybe search methods to solve specific musical problems. But at the same time, this methodology, which is not totally, I have to say that my compositional formation or my compositional background comes from, it's not specifically computer music. I come from the world of non-computer music, contemporary academic art music, let's say. So this methodology actually has faced me with a new compositional heuristic, let's say. And it has influenced deeply my creative thinking and also the logic of my artistic decisions making. So as I said, the very heart of the system is based on constraint satisfaction algorithms. But maybe I will talk very briefly about the philosophy behind it. Yeah, and you can see Hans Holger is there. I'm quoting him. Actually, I've been quoting him for a couple of presentations. He has a very interesting phrases. I'll read. So actually, since I started with this research, my inquiries for these projects have expanded. And now I'm not just interested in the purely musical sort of material and structural and symbolic musical issues. Now I'm sort of asking myself about the agency, the creative agency about this algorithmic system in my own creative process. There's a cool philosopher that comes from the world of cognitive sciences, that's Andy Clark, and he asks himself an interesting question. And he says, where does my mind end and the rest of the world begin? And for me, it is possible to rephrase that question, to pose it as, where does my creative agency ceases and that of the algorithm begins? And the phrase that Hans actually has posed very elegantly, it's related to the process of cognitive assemblage, this concept coined by Catherine Hales, between the human mind and computers in creative processes. And she says, humans and machines come together as cognitive assemblages in which the exchange process and the dynamic themselves becomes the central element. And whatever emerges from this connectedness is difficult to separate and attribute to either agent. So if we consider that an important element of the study of the psychology of creativity has to do with the process of searching for a result that has not been considered before as a pillar issue. Actually, in that sense, I can't deny the agency of this algorithmic system in my creative thinking and in my creative outcome, actually. So then I'm asking if then is it possible to consider this perspective on the creative agency of algorithmic composition systems regarding to the idea of cognitive assemblages, as described by Catherine Hales, or the idea of extended minds as proposed by Andy Clark? Is it possible as well to talk about extended creation or even co-creation in a way? There is another interesting question that has been floating around in my head. Is there any a priori reason to deny creative agency to non-human entities such as machines and algorithms? Since we don't know much about the heuristics involved in the process of decision making of music composers, it remains speculative. So some historical background for computer-assisted composition. We probably all know the work of Lehar and Hiller and the Iliac Suite, but I like to bring the figure of Yanis Xenakis as a pioneer in the use of computer-assisted composition systems. And there is an interesting reflection that he does after writing his very well-known essay named The Crisis of Serial Music back in 1955, and then the edition of Formalized Music in 1962. Actually, Xenakis, in my opinion, contributed to generate this rearrangement of the paradigms related to the use of computers and computer programming languages as means for music composition. And he has an interesting metaphor which describes his creative process involving probably the getting language, and he says, with the help of electronic computers, the composer becomes in a kind of pilot. He presses buttons, enters coordinates, and supervises the controls of a cosmic ship that navigates in the space of sound through sonic constellations and galaxies that before could only glimpse as a distant dream. He now can explore them easily, sitting on a sofa. So then we can talk about the Iliac Suite. It's agreed that it was probably the first piece composed by means of an algorithmic system. I think a constraint satisfaction programming system in the United States, in Chicago. I think it was in 1957 or 58. And actually, Leharen Healer and Isaacson, I think it's the other, yeah. So they take as the departure point for programming these constraint satisfaction algorithms, these treatises in Counterpoint by Johann Fuchs. So they took their rules, they put into the computer, and then they use this randomly generated material, and then that would be sort of constrained by certain rules, and then you get an outcome, which then you have to transform into musical notation. But Healer actually also proposed that it is possible. I think this is a very interesting idea regarding to what I mentioned about Xenakis earlier. It is possible to compute musical structures. And he refers to these musical structures as that are feasible to be computed as the objective side of music. And there is a quote of him that says, "The information encoded in the score relates to such quantitative entities as pitch and time, and is therefore accessible to rational and ultimately mathematical analysis." So this actually leads me to a further explanation for the choice of the title of my project, and also for further explanation on how it is implemented. So in this novel, 1984, George Orwell imagines this world, dystopic world that it happens in 1984, where this totalitarian government has taken over this collective state that is basically, what we understand now as the West. And historical denialism and propaganda have taken over Western civilization mainly. And there are these ministries which are, have the task of ruling this imaginary country, Oceania. And the Ministry of Truth is one of these ministers. And one of its roles is to generate content for culture and entertainment. And it does it through an automated process or an automated machine or system without any human intervention. So this fictitious generative system is known as Versificator, and it's a fairly relevant character on the plot of the book. But this idea of some form of art or any sort of cultural object that can be produced without any human intervention, it's seen as detrimental, by using these automatic systems and these autopoietic sort of things. Artistic decisions are, just delegated into some external factor, which, of course, it would be perhaps mechanical or repetitive or simplified and normative, and actually this object is considered as an instrument of alienation and cultural homogenization. This idea of that, floating the idea of that it takes a real artist to create something fine and extraordinary. and that the mere generation of content does not really reach the stakes of human creative production. So in the context of my artistic research, I decided to reframe this idea of Versificator as a technology that actually extends my creative mechanisms and provides me with a much more complex heuristics that are potentially deeper. It allows me to generate, potentially deeper or more interesting connections between musical ideas and musical material and musical structure. And now I'm going to show a little bit of what I've been. So this is how the interface of the system looks. So I have used this system for a couple of pieces, but for actually 4 pieces, not only vocal pieces, but also instrumental music. It has been fully developed in MaxMSP, as you can see, and relies on 2 libraries, 2 external packages. One of them is the Bach bundle, which provides me with this fairly well-developed music notation interface. Also, Bach and KH and Dada provide with a wide palette of functionalities. I'm using also another library called Mouse-Live, developed by Julian Benzenot, which contains an implementation of the PW constraints, which is a constraint solving engine designed by Mikkel Larsson. This is originally for PWGL, but it has been ported to Open Music and later for MaxMSP by Örjan Sandred, who is my co-supervisor in my PhD research, and also by Julian Benzenot. So I'm going to explain briefly what a constraint algorithm is. So a constraint satisfaction algorithm, it's used to find a combination of variables or to sort a combination of variables that satisfy a determined rule or a combination of rules, a chain set of rules. So these variables are picked from a domain, which is a set of elements, as you can see here. For example, in this example in music, this is a implementation of a constraint satisfaction algorithm in music. I'm using a set of MIDI notes. So the search engine will try all of the possible combinations for these variables and will sort them in the form of a solution that satisfies my desired rule here. So the engine is picking up 5 variables. As you can see, the rule here says that the first variable of the set should be n1 should be equal to 62. So my first note or my first variable is going to be 62, and then each of the successive variables should be larger than its predecessor. And then that goes through the search engine and you get a series of solutions. You can get 1 or you can get as many as possible. So that is the basic implementation of a constraint satisfaction algorithm. So there are actually 2 types of constraint satisfaction algorithms. There are the deterministic ones and the heuristic ones. This example here is a deterministic type. Since the engine will evaluate each possible combination of variables, and it will yield true if the combination enforces the rule or rules, or false if it doesn't. So each candidate solution is evaluated as yes or no for that rule. And the system outputs back only a solution if those rules are evaluated as true or yes. So any other combination, it's going to be rejected. So this is the type of deterministic algorithm. But there is another type, which is it's a heuristic algorithm. It's a heuristic solver. And I have chosen here an example which is not completely musical, but it serves the purpose of, for the sake of clarity, to understand how these heuristic solvers work. So for a solver, for a heuristic solver to work, actually, instead of yes or no, the engine will assign a weight or a ranking to each candidate solution. So then you can get solutions that fulfill partially the rule. I mean, you don't, the candidate solution does not necessarily have to satisfy the rule, but you'll get sort of a ranking of solutions. Then, of course, you can get a solution that satisfies completely the rule, so that will get the highest weight. But then also you can get a series of solutions that that do not necessarily fulfill it. So as let me just explain briefly this example here. So for example, in one of my pieces, I'm creating pseudo words. And for that, I'm using for my domain, I'm using a database of word prefixes, roots, and suffixes. You can get a list of those online. So each of like, I have this database as my domain. Oops, sorry, I'm gonna bring it back. So the heuristic rule for this case says that the whole length of the word, namely the number of letters, should be equal to 20. So then when you pass your domain through the search engine, you will get, for example, solutions that are ranked, have lower ranking. For example, this EP50, which has 6 letters, will have a very low weight, but these other combinations will yield better weights. Therefore, they are better candidate solutions. Of course, it may be within the combination of all of your domain, you don't have a word, you don't have the possibility of reaching 20 letters. You may have, like, the longest one is going to be 18. So that's going to be your better candidate solution here. So the interesting thing with these heuristic rules, since they are not deterministic, is that you can play around with contradictory rules. I think the more clear example of a type, not necessarily contradictory rule, but like a colliding sort of set of rules, is the when you use a melodic profile as your rule. So you have a graph of a function which tells you, this is the profile of the melody that I want to create. But then, so that's going to be heuristic. And then you have another deterministic rule that says that all of the intervals, you can only use intervals of fourths and seconds. Then, so of course, the profile is not going to be perfectly as you shaped it in your function, but somehow it will remain, there in a way. So the algorithm will look for the most suitable combination of intervals of fourths and seconds that sort of shape a kind of melodic profile as the one that you want. Of course, these constraint satisfaction algorithms, have provided me with the opportunity of handling massive amounts of possibilities or potential solution for my specific problems. And I guess this is what I mean when I discuss this idea of expansion of the compositional, logic, when, being otherwise impossible to go through all of the iteration, even the possible iterations, not to speak even the ones that are not, not even close of satisfying the rule. Anyways, so what I'm going to show now, it's an excerpt of a piece that I wrote based on constraint satisfaction algorithms. I have used them extensively. I might speak of maybe one implementation of the algorithm. So, but let's just listen to it, just maybe a couple of minutes, and then I'll go back to explaining how it works. So this is called render 3. It's not a very original name, but and this is the Schola Heidelberg vocal ensemble. So let's just listen around minute 3, maybe. Okay, so so for this piece, I have I created 4 different modules that generate different types of musical material. As you might have heard, I'm using consonants, I'm using IPA vocalic sounds, and I'm also using words like IPA. So actually the words that I create are not in IPA. I actually had to translate them into IPA because since they are pseudo words, they don't exist in any language, and therefore you can't get a correct IPA translation. Let's say online, you have to create your own IPA translation. So you could see the pseudo words on top between columns and below the IPA translation that I did for each of the words. Then another, so each of these musical materials is generated by an implementation of a constraint satisfaction algorithm, which have rules. I'm going to explain a little bit of the pseudo word generator now. And then I used also an implementation of a constraint engine to determine the formal level of the piece by determining the temporal disposition or the temporal array of the musical material. Oh, I'm sorry, I can't. Yeah. So as you saw, I am generating these pseudo words, which are words that are stochastically generated by combinations of prefixes, roots, and suffixes. So what I'm controlling mostly is some of the formal rules for the succession of words. So you can control the pattern, for example, of rhyme. You can determine a pattern of alliteration, or you can become much more complex and microscopic, and then determine the length of the word, or even determine what I use in this piece which is for example, the proportion between, let's say, consonants and vowels in a word. You can create a word that has more consonants, or you can create a word that has more vowels, and so on. So you can actually get quite deep in terms of what rules do you want to enforce by creating words. Okay, so maybe now I'll move into another piece that I also wrote sort of by using an implementation of constraint satisfaction algorithms. So this is a choir piece that I wrote as a response of a madrigal by Claudio Monteverdi, Io mi son giovinetta. And for this piece, I actually was driven by the idea of resynthesis at different levels of musical and poetic constructive parameters. So my proposal of the concept of resynthesis here actually proposes a type of deconstruction and new renderization of a work of art passed through what you could call a lens or a sort of a crystal, which is an artificial process which alters somehow the nature of its originally constructive nature, but in a way keeps some resemblance to the original version. And so for this piece, actually, I used two main methods in order to resynthesize it. So the first and probably the more interesting, maybe I would say, is just the use of a Markov chains to generate an alternative version of the text. Of course, it is possible to use Markov chains to generate different probabilistic matrices that are more or less deviated from the original, depending on if you're using, depending on the order number for the Markov chains. So what I did is basically I took the text of the madrigal and I created 3 new resynthesis of it using different Markov chains orders, starting from 1 up to 3, I think. And another type of resynthesis that I used is the one that has to do with the deconstruction and posterior reconstruction of the concept of modality. So I created my own rules for the succession of melodic elements and also the succession of the combination, vertical combination of notes, in the way that each section of the madrigal would resemble some type of musical texture from the Renaissance or even from Middle Age. For example, this cantus or the melismatic counterpoint, or also the type of texture known as cantus firmus. So what you will see, you will hear here is just a fragment of it. And it's nice that we have an Italian attendant here, because this is a resynthesis of the Italian poem by Giovanni Boccaccio. It's nice because it's kind of sounds Italian, but of course it is not. So I'm gonna play just maybe. Okay, maybe that's enough. So I'm not sure how am I doing regarding to time, but I might just have another fragment of a piece. But shall I stop here, or I don't know?
We can have listen to another one.
Okay, yeah, it's gonna be a short one as well. So the not you. Oh yeah, so here you can see how the I mean, this is I have seen other attempts of resynthesizing text using Markov chains. So this is the original text, and of course you can use it in Markov the order 0, which is just a random combination of letters and spaces. Then of course you can move into order 1, and there are some more closeness to the original, and you get to order 3 or 4, where you can get actually some actual words from the text. Actually, I didn't use the order 0, which is the random combination. I didn't find a way of implementing it, but yeah, but the piece is basically, you know, switching. Actually, it's moving from order 1 into the original version of the madrigal at the very end. So another piece that I wanted to show is a piece for solo trumpet. It's called elevator pitch. The elevator pitched, or elevator speech, it's a kind of a short statement or a short description of an idea or a product or a concept in a way that any listener can understand it in a very short period of time. And actually the word elevator pitched refers to the idea of that you should be able to explain something on the time that takes an elevator to go from a floor to, I don't know, the time of a ride, an elevator ride. And so for this piece, what I'm doing is maybe I should talk about the idea of rhetoric figures in the antiquity, but that's going to take a long time. So basically what I'm doing here is exploring the transformation of rhetoric figures or rhetoric schemes into musical material. Mostly melodic gestures and phrases. And I'm generating a type of narrative that is based on a rhetoric plan. There is you can go online and see and find a rhetoric plan, and you will get a sort of a energy plot where you know at the climax of the graph is where you are supposed to have these rhetoric gestures that convey more energy. So it's a sort of an abstract map for an elevator pitch that you have to feel as if it were like a musical form scheme. So for this, I developed a series of rules in a constraint satisfaction algorithm, which allow me to shape a set of incoming variables, in this case pitches and intervals, according to my own personally and arbitrary, maybe not so much, interpretation of the musical equivalent of a literary rhetoric gesture. I mean, it's not completely arbitrary, since there are previous studies that have studied and that have explained or tried to systematize the use of rhetoric gestures in the musical rhetoric gestures in the music of Claudio Monteverdi, but also in the music of the other early Renaissance or early Baroque composers. So that's what I've been doing for this piece. Maybe I could probably listen to it, and then I might show an example of the rules that I used for that piece. Oh, I have to, yeah. This is probably where the score is showing. sorry, I'm gonna. Okay. Yeah. Yeah, that was just the very last fragment. It's a piece of like 7 minute long, but yeah. Okay, yeah, no, that's pretty much it, I suppose. So I'm gonna just stop sharing the screen. Yeah.
Well, thank you so much, Juan, for this wonderful presentation. Maybe I can start with the first question. So, well, one of the things I was thinking about while you talked, or I kind of tried to understand regarding the way you use constraint processing, was like a kind of strength of constraint processing, like, which is I think also why it has been used like for counterpoint things as always, like a kind of example, as you've also mentioned, is that it's really good if you have something that has kind of multiple dimensions that are still interconnected. Like you have melody and harmony, a decision in one dimension has a consequence on the other, and vice versa. So the harmonic constraints constrain the melody and the other way around. And this makes it hard for us, for humans, to kind of navigate that, because we take a decision in one thing and then it constrains in some way the other, and so on. And constraint processing allows us to kind of take it apart and say, okay, these are the melodic constraints and these are the harmonic constraints. And then suddenly these dimensions are kind of connected, and this crazy convoluted space gets much more easy to navigate in a way, because we can just formulate it. But I was kind of wondering, like, how in the examples that you've showed, the way that you used it, it seemed to me more like you apply it to one dimension. Did you kind of like do something like that where you connected like multiple dimensions? Like, for example, you could say the text and the melody, I don't know, there is not that much immediate connections. It would have to be dimensions that are really also affecting each other, sort of, in reality.
Yes, absolutely. So I guess two things come to mind. There is actually the possibility of using constraints in multiple dimensions, as you mentioned. There is actually an implementation of a constraint algorithm called cluster engine, where you actually take each of musical parameter as one of your domains, and then you can create an integral. You can create rules for each of them, and you can make actually the rules interact. The most obvious example is, for example, I want to see the note C with a quarter note in rhythm, and that's the very basic stuff. It can get much more complex. But in the example of the vocal ensemble piece, actually, I have used multiple dimensions for the implementations of the constraints algorithms. The one that comes to my mind very, very quickly is whenever you create a word, whenever you create a pseudo word, of course, you're creating a pseudo word without any musical implication, but I have coded some rules that say that depending to the vowel that comes, because that I have to sort of hyphenate them to put them into a vocal score, let's say. So depending on the consonant or let's say the vowel structure of the word is the pitches that you can get. So if you get an then you will get a set of pitches as a harmonic field, which is related to that so that creates in a way the sensation of a harmonic field for each individual vowel. So I'm using a type of mapping between the form and structure of a vowel into musical pitches. These form and structures are just resonating bands. You can map them into musical heights, and you get a sort of harmonic field consisting of 4 or 5 notes, depending on how many formants you want to use. So every time you get a vowel on that pseudo word, you will just get a harmonic field that is related to that vowel as a harmonic field derivated from the form and structure of a vowel. So that's the example that I can tell. But I have also used that for the rhythmic construction. So yeah, I mean, it's definitely in my mind. I mean, you can use the constraints algorithm as sort of like just to control your melody. I actually did that for the trumpet piece. I'm just controlling the pitch system. I'm not using a kind of b-dimensional constraint satisfaction. So I'm getting my rhythm from a different process, let's say. So for the trumpet piece, yes, I'm just using the engine as a way of determining my succession of notes. But yeah, absolutely. I mean, I guess that's the strongest maybe feature of these constraints algorithms, that you can just use them to work interactively between musical parameters, and that also gives you probably, I mean, that enforces this idea that I have of creating more interesting or more deeper relationships between musical material and ideas, and you're creating sort of objective relationships between ideas and musical material or musical structure.
Yeah, thank you. That's super interesting. I have just as a sort of side note, I've written a paper that was published I think 2 years ago or something in Computer Music Journal, that about constraint processing and using it for like kind of the physical motions of a performer, especially for wind instruments. Like I've developed a software where you can like basically the kind of things you would have normally in these manuals, in these handbooks of whatever clarinet or saxophone or something like that, like the kind of fingerings and the motions of the fingerings, and to connect that to pitch or multiphonic spectral pitch content or whatever kind of constraints on the pitch, so that you can like connect these dimensions, the playability and the pitch. So that was some area where I went into that constraint processing. But I have another kind of follow-up. If you want, I can send you that.
Yes, absolutely.
Paper.
Yeah.
The other question just was also like an idea that came up when you talked about the kind of Markov chains and the idea of resynthesis, which I also thought was really interesting and striking, like to take music and kind of resynthesize it or analyze, resynthesize like the kind of music and the languages on it. And then like when you do that, some kind of analysis like Markov chains are, in some sense, you get like to another realm, it's almost like it's like another domain, and there you can do other transformations, and then you can go back a bit like whatever, like a frequency domain or something like this can do. And then I thought like Italian does have like a really strict morphology, like it kind of has a vowel has to end in a syllable has to end, I think, mostly in a vowel, right? Can you end a syllable without a vowel? I think you cannot really.
Yeah.
Or maybe on certain vowels, on S, I guess you can end or something like that. Well, anyway, but there are relations like to other languages. I think Korean also has something similar, or like languages that are not really related closely, but that have similar kind of very constrained morphology. So you could almost like with the Markov chain kind of morph it into Korean probably, and would almost be the same, maybe almost be the same probabilities or something like that. I don't know, that was just something I kind of came up like, would it allow you also to then make like a new connection and resynthesize into some like kind of like morphing between two different sounds in with frequency analysis or something like that. Like,
well, I'm not sure if I get totally the question. I guess the interesting thing about the I mean, something that I did in this piece is not just resynthesizing the language, but also trying to respect the metric structure. So I used, well, I didn't mention it, but I used constraints in order to get a solution for the Markov chain which satisfies certain rules. So you get a rhyme scheme. There are no alliteration patterns. I think I just got the rhyme scheme, but I also used the I created how do you say it, like the syllable structure, which is the same than the one of the poem. So I guess it's not just an implementation of Markov chains, it's a bit more complex than that. I guess that in a way that conditionates the output. It's not what you would get out of a random, like a regular sort of resynthesis of the probability matrix of a Markov chain. So, and then the use of different Markov chains actually, which gives you a kind of more even close result that leads you into the language. I thought that was an interesting thing, because I have seen many resynthesis of language. Actually, one of the tutorials for using Markov chains in Bach is just taking some Shakespeare and creating a resynthesis of it using order 0, 1, or 2, or 3. So that's a very simple thing to do. I thought in this case I would have to sort of give it a little twist in order to make it, I don't know, original, let's say. I'm not sure if original is the word, but at least more interesting. I think Markov chains is a very, very powerful tool to use, even nowadays, even though, the Iliac Suite was pretty much based on Markov chains, I think the last movement. I think there is a lot of potential on it, but I think also it's interesting to combine these two tools, the Markov chain probabilistic method and the constraint satisfaction programming algorithms. That's an interesting one. I think I'm exploring that actually for a new project that I'm starting now. Yeah, it's a whole it's a whole world, and it gives you way more possibilities that I can handle. But yeah, I guess one of the things about composing is just making decisions, and some of them can be just very intuitive in a way, and just exploring and figuring out ways of doing things. But yeah, no, it's definitely interesting. Markov chains are a very interesting tool for composing.
Thank you, Juan. Maybe someone else of the others here has a question.
Yeah, thank you, Juan, for the very nice presentation. I would have a question that was going through my mind while you were speaking. We were often talking about how you can get a set of solutions out of this constraint solving, so to say. And I was thinking I was wondering whether you have any kind of strategy to then select out of this solution what's going then in what you're going to use, so to say.
Yeah. Yes, that's a great question, because of course the engine can give you as many solutions as possible, or can give you just one, or can give you solutions in random order, or it can give you the solutions sequentially. So for the piece that the piece for vocal ensemble, actually each of the modules you can just bang it, and you will get a solution depending on the rules that you set. And so the way I choose them is just the ones that I like. that's a very strange response. It doesn't really it doesn't really favor my argument of, I don't know. I mean, I guess one of the interesting things about this is that I don't see it as, worshiping the system. I'm not really interested in getting, an outcome from the system and just putting it into a score and then, oh, this is the result of my system. So I'm more interested in reacting to it and interacting with the solution. So the way I see it is, you get some material, but then you have to work on it. And if you just sort of put in the score the result as it comes, it might not be the most interesting thing to do. Actually, if you looked into the score of the vocal ensemble piece, there are a lot of writings, a lot of indications added by me. Of course, you have to do a lot of editing, and then you have to get that score in format XML that comes out of Bach, and then you have to take it to Sibelius and work on it. But one of the things that I felt, or sort of drives me and drives my work, is not just taking the output of the system as it comes, but just responding to it. And one of the ways of responding to it is choose whether I like it or not. I guess that's, I mean, I don't have a strategy to choose the solutions more than just the very, subjective and personal appreciation of what comes out.
Well, taste is also a strategy in the end. But I'm interested in this kind of feedback that you can get out of this process, right? So maybe I have also a follow-up question then, like when you find yourself confronting with these possibilities and choosing what you like or not like, so to say, and then what can work in your piece and what not. Do you also have further ideas for going back and developing the system that gave it?
Yeah, absolutely. I mean, each of the modules started as very basic tools with very basic functionalities. And as along my experimentation with them, I would go back to the the editing mode in Max and just create some new rules and finding new combinations. So actually, I'm still developing this system. It's quite how you say it. I mean, it's not it. I'm more than everything. I'm adding new modules. So each of the pieces actually takes, I mean, if you want to write a piece for, different instruments or using different musical material, you would probably have to tweak the modules, of course, because originally it's sort of more focused to vocal music. And, every time I have an idea, I'll try to create a new module based on that. So far I have like 8 or 9 modules, which allow me to compose for instrumental, for instruments or for voices as well. And actually I'm working on one, which is completely, symbolic processing. I just get A, B's and C's, and that A, B's and C's just, it's mapped into a musical domain. I don't get any notation, so to say. So that allows me to work with whatever parameter I'm interested in. I mean, just for example, the theatricality of the performance, right? You can just say, okay, this is A, this is B, and whatever. I mean, it's just this very basic symbolic kind of process.
Yeah, nice, thank you.
I would also have a short question, and it goes into a similar direction and as Daniele's question, but maybe going the other way around. So, how would you say, and also recalling a little bit that citation that you picked out from Hans Holger's work in terms of thinking.
Sorry? Citation by who?
Hans Holgers. Hans Holgers from Hans
Oh,
Holgers' work.
Hans. Oh, yeah.
Thinking in terms of assemblages. How would you think, or how would you explain? I know it's usually difficult, but how would you think that the work with these algorithms, or that particular way that you have developed in working with these algorithms, have changed your way of composing?
Yeah, it's a great question, actually, and I guess it's the key. I guess there's a lot to say about that, but so in a way, basically the possibility of having this massive amount of information just at the reach of writing one rule and getting all of these possible results, which in a way, of course, you can't even think of going by hand through all of the iterations of, all of the possible combinations of a set of variables. That's one thing. But another way probably comes up when I'm thinking about the formal array of the musical material. There is a type of mathematical thinking that you can use that you can implement on using constraints algorithm, which is for me totally new. I mean, for example, what I'm using for the vocal ensemble piece is I'm using time scalings for the materials, and of course you can get, that's a number, so you can do whatever you want with it. But an interesting thing is that, for example, I can think of these scaling factor values, and then I can create mathematical operations that then will, work as my formal combination of material. I mean, I'm not sure if I am being very clear. Actually, I'm being very vague here, but these type of operations, which probably are more in the mathematical side, have really, I don't know, changed my way of thinking, or at least opened up some new possibilities for organizing material. Yeah, but I would have to probably talk about each specific piece and the details for that piece. But yeah, I'm not sure if I'm answering, but yeah. Yeah. Yeah, I mean, just to sort of try to be more specific if I can, but like I was talking about these sort of the time scaling factors. You can actually have a mean for all of the time scaling factors that you want, and that's a section. You will just use time scaling factors and combination of them that are close to certain mean. I mean, I wouldn't have thought of that as a compositional possibility without using computers or without using constraints. I mean, it's just a too complex way of thinking, or it's just too speculative way of organizing your material. But I guess that's what I meant when I was saying more on the mathematical side of the, of these. I guess those sort of thoughts have, I mean, those sort of thoughts are quite new on me. I wouldn't have proceeded in that way before, let's say.
Yeah, thank you. It's
yeah.
Interesting. Thank you for your presentation. It was really interesting.
Yeah, thank you. Thank you for inviting. This is a very interesting group, and really enjoy every presentation. So I guess this is the last one, isn't it? I don't have any other in the schedule.
Up to no, I think there is still the presentation by Gerhard and Ludwig, at least.
Okay. Okay.
But we can extend these presentations. I have already put up more dates to choose from on the doodle. But we probably will send a reminder email out in the next probably week. So that those that have not yet done a session are free to choose a new session. Probably Daniele also if he wants to, and Bjarni, I think he wanted also to postpone. Yeah, I guess that's basically going on with our sessions, and. Yeah, and I hope we will get a little bit more. I know that everybody of us has a very tight schedule, so it's sometimes difficult to find space and time for this session. But I think the format is quite nice. I'm really enjoying usually.
Yeah, absolutely.
This informal way of presenting and listening to the works of others. It's working on this. With this respect, and I also see that on YouTube we have listeners and viewers afterwards, so probably that's also happening.
Yeah. I'm gonna post it on Facebook or.
Yeah. I think that for today, also looking at the clock, I think we can call it a session. Or do you have? Is there anybody else that has a question for Juan? No. Okay. So, yeah, I think that's it. Thank you very much for your presentation. It was really
Thank you, Juan.
Yeah, thank you.
Thank you, Juan.
Looking forward to hear and see more, and I think we can stop here.
Okay.
Thank you very much.
Okay. Yeah.
See you soon.
Yeah.
Bye-bye.
Bye-bye. See you.
Off air.